Hello all, what you see here is a block diagram of a DC-DC converter where you have the power supply and you have the PWM generation and you have the MOSFETs configuration here. So, uh, we are going to know about something called dead time control. So if you see here in the configuration, for the high drive of the MOSFET and low drive of the MOSFET, there is a block which says gate drive logic, which is clearly understood, and dead time control. What is this dead time control? So here if you see, this block is going to generate the drive for the high side MOSFET and the low side MOSFET. So we know, right, high side MOSFET, you will have power supply connected and then the other load is connected towards the source side. Whereas in the low side MOSFET, you will have ground connected to the source and then you have the output on the drain side. So there is a simple configuration where high side and MOSFET are combined together to form a bridge, right? So this is a common configuration which we see in the regulators, the switching regulators basically. So in switching regulators we use a PWM where the PWM switches these MOSFETs to have the required output on the V out pin. So what do we mean by switching? Switching means it's just turning on and off. Every one of us know, right? So imagine a scenario where you have the MOSFET, the high side MOSFET turned on and the low side MOSFET also turned on. So there is a direct shot from this point, this node to the ground, and this node is nothing but the power input to the MOSFET. So you see a direct shot between the power and the ground, which brings in a scenario called shoot through. Shoot through is like a large surge of current passes through this because there is a short of these MOSFETs, right? So when you are operating this regulator, you need to understand that you must not have a scenario where both of these are turned on or off. Like example, if we see, okay, uh, if we have a waveform like this, let us assume, okay, for the high side MOSFET, let us assume this is a high side MOSFET control, PWM control. We are assuming 50% duty cycle here for now, okay, and then when the high side is turned on, we said the low side should be turned off, right? So it must have the waveform inverted of this, right? Simple to understand, right? So if you see a scenario here, okay, at these edges, when the high side MOSFET is going, when the low side MOSFET is going low, the high side is going to turn on. But the instances at which this happens, there is a overlap, which should not be the case. In this case, what happens is there is every chance that high side and low side MOSFET can turn on at a time. So what should happen is when you are turning off the low side MOSFET, you should take some time and then turn on. And then again, after you turn off, you should have some time to turn on. So you see the gap here, okay? This gap, the time difference should be maintained between turning on and off of the high side and low side MOSFET. That's what this dead time control is going to ensure, where you will not have an overlap of turning on both the devices at the same time, ensuring a direct shot from power to ground or shoot through condition which we were talking. So that's where this that time comes into picture, and which is a very important concept in power supply regulators. So when you are operating, or when you are using these kind of configurations in motors where you generate the PWM control to the DC motors control circuit, PWM control circuit, which the microcontrollers, for example, are going to generate in the microcontroller. You should have to ensure this dead time is implemented. But if you take the chip, regulator chip that is available, like the example one which we are seeing here, the dead time is dead time control is ensured. So when you are selecting a regulator, see that this feature is available, and most of the regulators do have this feature. And as we mentioned, when there is external control, it has to be taken care by the user. Thank you.